Hi guys, so in this video we will be solving this problem nth palindromic binary. So let's understand what the problem says. So according to problem we will be given a number n and we have to tell the nth palindromic binary, means nth number whose binary representation is a palindrome. So what do I mean by it? Let me explain you it in a minute. First let me quickly write some binary numbers whose binary representations are palindrome. So the first number is 1. How I'm getting these numbers I'm going to explain you in the later part of the video, but for now the problem statement I'm just explaining what does the problem demands. So 1 1 1 1 0 1 1 1 1 and 1 0 0 1 1 1 1 1 and so on, yeah, and so on. So okay, so this is first, this is second, this is third, this is fourth, this is fifth, this is sixth. Okay, so if n equals to 3 is given to us, so what do I mean by it is that we have to tell the third number whose binary representation is a palindrome. So the third number whose binary representation is a palindrome is 101, and if you convert it into a decimal, the answer would be 5. So 5 will be the answer for this case. So similarly, if you ask the fourth number whose binary representation is a palindrome, so the fourth number is what? 111. So if you convert it into decimal, the answer will be what? 7. So 7 will be the answer. Okay, so similarly any value of n can be given to us and we have to tell the nth number whose binary representation is a palindrome. Okay, so this was for the problem part. Now let's see how we can solve this problem. Okay, so if you directly, like suppose if some value is given to us n equals to 24, and if you directly try to solve like how can we get the number 24th number whose binary representation is a palindrome, so it will be like a little difficult. Like how to think in this direction could be a little difficult, like to find out some patterns would be difficult. So what we can do is that we can think of this in a little different way. Let's first try to find out some numbers whose binary representations are palindrome. Okay, so few numbers are given to us, means I have written few numbers. How I am deciding whether a number is palindrome or not, let's see. We all know, means the conditions for palindrome, like if suppose there are 3 bits, so what we need to ensure that first and last bits are same. Similarly for second last bits and so on, that first and last are same, these two are same, these are same, and so on. This is what we do for palindrome. So this is the basic condition that we are going to use over here. So for how we started over here is that we want numbers whose binary representations are palindrome. Okay, so the first number whose binary representation is palindrome is 1. So how did we got 1? We started with, what could happen is that the number could be of 1 bit, could be of 2 bit, could be of 3 bit, 4 bit, and so on. So we started with, for the smallest number, we started with the lowest bit first. Okay, so if the number is 1 bit, is there a number whose representation is palindrome? So we said yes, there is a number. If we simply write 1, then it is a palindrome. So we chose 1 as our answer here. You might be thinking that 0 is also palindrome. Like if you write 0, then it is also palindrome. Yeah, but it is also palindrome. But let's suppose I tell you to write a 4-digit number. You write 0400, then is it a 4-digit number? No, since it is started with 0, so we are considering it as what? 3rd-digit number. So number should start with 1. So that is the case here also, that's why 0 is not considered. Okay, now after that there is no other number possible with 1 digit, so we move on to the 2-digit. Okay, now for 2-digit we know that starting and ending digit should be same for palindrome, and first digit should be 1 if it is a 2-digit number, so second digit should also be what? 1. So for 2 digits there are also only one possible number, that is 1 1. Okay, now we move on to 3rd digit, 3-digit numbers. Now for 3-digit number, first and last digit are 1 for sure. Okay, now for the middle digit we have 2 options, it can be either 0 or 1 since it is binary. So the 2 numbers possible are 101 and 111. Okay, now we move on to the 4-digit numbers. Now let's find, are there any 4-digit numbers which are palindrome? So first and last digit will be same. Okay, now for palindrome the conditions that reverse should be same, so these 2 numbers will be exactly the same. So we do not have 2 possibilities over, we have only 1 possibilities, that we can fill some digits over here. So there are 2 possible options, 0 or 1. So our numbers are what? 10, 01, 11 and 11. So these 2 numbers over here. Okay, Now let's move on to 5-digit numbers. So what if there are 5-digit now, if you select 5-digit number, so for 5-digit numbers we can see that these two digits should be same, these two to be same, and first digit is 1 only. So basically how many options do we have? Yeah, 1 second. Yeah, so for 5-digit number, uh, basically these two will be same and these two will be same, and first digit is 1 only. uh, 1 2 3 4 5, these two will be same. So basically we have options at these two places. So these two can be what, 0 0 or 0 1 or 1 0 or 1 1. So our numbers will be what, 1 0 1 1 0 1 1 1 1 and 1 1. So these four will be our numbers. So for 5 digits we got 4 numbers which are palindrome. So let's write those numbers. Numbers are 1 0 0 0 1, 1 0 1 0 1, 9 1 1, 1 0 1 1, 1 1 1 and 1 1. Okay, now we move on to the 6 digits. Similarly, let's try to find for 6 digit. For 6 digit, 1 2 3 4 5 and 6, these two will be same and these two will be same and these two will be same. So first digit is 1. Okay, so now basically we have only two possible options here and at this point and this point. So here also we got 0 0, 0 1 1 0 and 1 1. So our numbers will be what, 0 0 1, 1 0 1, 0 1 1 and 1 1 1. So 11th number will be 1 0 0 0 1, 12th will be 1 0 1 1 0 1, 13th will be 1 1 0 0 1 1, 14th will be 1 1 1 1 1 1. So these are the numbers. Similarly we can generate more numbers also. We will, if we need, we will generate more numbers. So how we are going to approach this problem is that we want nth palindromic numbers. We see that for one length we have only one some representations with some numbers. For 2 length also we have some numbers. For 3 length we have some numbers. For 4 length we have some numbers. For 5 length we have some numbers whose representations are palindrome. For 6 length we have some numbers whose representations are palindrome. So I want nth number whose representation is palindrome. So what I can do is that I will maintain a counter equals to 0 and length equals to something like counter 0 length 1. I will first check length equals to 1. What I will do, how many representations are there in this particular length. So I am seeing that there is only one representation, and let's suppose I want the 13th number whose representation is a palindrome. So I will say that okay, I have got only the first representation, I want 13th representation, so I will add more. So I will increase my length to 2. Now I will check for 2 length, I got only one number over here also. Now I'll move on to 3 length. How many numbers I got? I got 2 more representations. Okay, now I'll move on to 4 length. How many representations? I got 2 more representations, and so on. I will count till I not find a representation equal to my number. Okay, I will do something like this. Let's do whatever I have told right now. Let's try to code this part for now, and I will later explain like what I'm trying to do. So what I'm trying to do is that what we'll do, we'll make a variable counter equals to 0 and length equals to 0, or let's make counter equals to 1 and length equals to 1. What we will do, while counter is less than length, okay, what we will do, integer number of strings equals to O. For that we need a formula over here also. Let me write the formula for now. I am going to explain the formula, like how I got this formula. 1 left shift of length minus 1 divided by 2, okay, and plus length and count plus equals to number of strings. Okay, so what we did is that we want like 13th palindromic number. Okay, so we know that there are some palindromic numbers in each length, like 1 length has some palindromic number, 2 length, 3 length has some palindromic number, same for 4 length and 5 length, they have some palindromic number. So my number could be of any length, like 13th palindromic number, it could be of 4 length, like 13th palindromic number. In this case it is lying in 6 length, so it could be of a 4 length number, it could be of a 5 length number, 6 length number, 7 length number, or a 8 length number. Okay, so what I need that what is the length of this particular number, or in some way I need some information about this number. So what informations, like what I need will I get? Let's see from here. Okay, so what I did, one by one I initially started with length equals to 1, length equals to 1. How many numbers are there? There are only one numbers. Okay, I want 13. Okay, now I move on to the next length. How many numbers? One length. I want 13, so I move on to the next length. 3 length. 3 length, how many are there? Plus 2. I want 13. I move on to the next length. Okay, I 4 length. 4 length plus 2. I want 13. I move on to the next length. 5 length plus 4. Still there are only 10. I want 13. I move on to the 6th length plus 4. Now I got 40. No, now I stop. I want 13, 13th palindromic number, but I got 14th palindromic number. So I got some information from here. What information? That this is of 1 length, this is of 2 length, this is of 3 length, this is of 4 length, this is of 5 length, this of 6 length. Till 5 length I was not getting, I was getting only 10th palindromic number, but after considering 6 length I got 14th palindromic number. So 13th palindromic number lies in what? In 6 length series. I got some information from here. So what I can make, I can make a number of 6 length, right? I know that it is a 6 length number, so what I will do, I will make a number of 6 length. I got some information from here, so I can make a number of 6 length. 1 2 3 4 5 6. I got this information from here. Now I need some more information. So what I need is that my number is what? 13th number. Okay, so what is the means? These all numbers are following some pattern. If you look all these numbers, what are these are 6 numbers. Along with that, if you look over here, these are what? 0 0 0 1 1 0 1 1, and rest part is just reverse. So they are just following the binary pattern, means 0 0 0 1 1 0 1 1, and this part is what? Just reverse of this part. So we need also this information also, like what pattern these are following. Okay, so if you could means figure out this pattern also, then it would be helpful. So like you can figure out this also. How? We know that this is 14th. Now we have 14th number. We don't want 14th number. We want, I know that this 13th palindromic number lies in this 6 range series, means this the elements having the numbers having 6 length, it lies in this particular range. Okay, so what I will do, 13th is what number? If I see from here, 10 plus 3 is 13, right? Then this binary is what? 3. And if in binary we start, means here we are starting from 0 1 and 2, so we are writing the binary of 2 over here. So what I can do, 13 is what number? The last number plus 3. I can get something like this. This number is 10. If I subtract the current numbers, that is 4 length, whatever the number of elements in the current series are, like in the 6 length series there are 4 elements, and I know how many elements are in the current series. If I subtract this number from 14, 14 minus 4, I will get what? 10. And which number I want? 13th. Here it is 10th. What is the serial number over here? 13 minus 10 is what? 3. And binary, what binary I am storing? I am storing binary of 2, since 0 1 2 binary starts from 0. So for 3 I will be using 2. So 3 minus 1, what I need, I will make a 6 length over here, and I need to what? Insert a binary of 2 over here. Means what will be the binary of 2? 1 0. First character is 1, then I simply need to reverse this part over here, 0 1 1, and I will get the number. Okay, so I need some these information only. I got the first information. First information I got that 6 length. Okay, second information, I need offset, like what is the position, what is the position, since the numbers are what? According to binary, 0 0 0 1 1 0 1 1. So what is the position? So I need the offset. So I can get the offset, like here it is 10. So what will you, and I want the 13th. So I can get the 10 by subtracting the value from here, like what? 14 minus 4, the number of elements in the current range. If I subtract that, I will get 10. So 13 minus 10, I will get this range. Okay, so I need offset. Okay, so I will get the offset. After that, what we have to do, we simply need some bit manipulation, like, and we'll be able to generate our number. Okay, so let's calculate these parts. How will I be able to calculate how many numbers are in the current range? So I have used a formula while coding, and I have told you that I'm gonna explain that. So let's understand that part. So we can see that how many numbers are there in a current length. So we want to generate palindromic numbers. Okay, so in the current length, how many numbers will be there? Let's suppose there are 3 numbers. So we know that these 2 numbers will be same, these 2 numbers will be same, and first and last will be same, and first position is already reserved. Okay, so we have choices only at these 2 locations. Okay, these 2 places, so that's why there are only 4 numbers. So how we are getting this? So we want 2 numbers. So we can write this something like this 6. If we write 6 divided by 2, we get 3. So this is not a correct option. So we can write it as what? 6 minus 1. 6 minus 1 divided by 2, that is, we got now what? 6 minus 5 divided by 2, we got 2, and every bit has what? 2 positions. So 2 raised to 2 is what? 4. So the number of characters, means the number of possible strings at any particular of any length, will be what? 2 raised to power length minus 1 divided by 2. This is the number of strings at of any length. Let's suppose we have a 5 length character, 5 length string. So how many options do we have? We have options at this particular cell, at this particular location, and this particular location, like 0 0 0 1 1 0 and 1 1. So we want to give, and because these two are same, and not these two are same, and last two characters are same, the first and last are already fixed as 1. So we have options only at two locations. So how we can write it? As we can write 2 raised to power length minus 1 divided by 2, 5 minus 1 divided by 2, 2 raised to power 4 divided by 2, 2 raised to power 2. So that is correct. So this is the formula. The number of strings in any length is what? 2 raised to power length minus 1 divided by 2, and that is what I have written over here. 2 raised to power length minus 1 divided by 2. I have written it using bits. 1 raised to 1 left shift left minus 1 divided by 2. Okay, so after performing this, now let's continue with the algorithm. What we got? We'll break when we have a value of 14. So we got to know that length is what? We will be, after this loop, we will have the length, but we want the offset. So offset will be what? For offset, what we did, we will subtract the number of strings in the particular length. So we will get back to what? 10. After that, we will simply subtract 13 and 10. So what we will get? We will get the offset for this particular, means the offset for our string. Okay, so after this, what we will do? Count minus equals to the number of strings in the last, in the current length. So what we will do? Count minus 1 left shift of length minus 1 divided by 2. Okay, now offset is what? Offset is what? This, whatever our value is, minus this. So that is n minus count minus 1, because 13 minus 10 will give us what? 3, and we are storing binary of 2, because binary starts, we are starting with 0 1 2. So we will store 1 less than that. So we will store we are storing minus 1. Okay, now we know that our answer is of what length. So let's make a variable answer. We know that our answer lies in range of 6. So we will make a variable of length 6, something like this. We can make 1 followed by 5 zeros, 1 2 3 4 5, 1 1 2 3 4 5. We make something like this. So 1 left shift of length minus 1. After that, what we know, that we have the offset, like what should be the positions over here. We got it in the offset. So if our offset is, let's say, what is the offset? Offset is 0 1, let's suppose. So we want 0 1 to be over here, like we want our number to be something like this, 1 0 1. So how we will do that? We have 0 1 as our offset. If we left shift it by length by 2, here length is what? 1 2 3 4 5 6, 3 by 6 by 2 will be 3. So if we left shift it by length by 2, so this will get something like this. 0 1 will come over here. Okay, now if we perform the OR operation, what we will get? OR operation, this is for OR operation. So we will get what? 1 0 1 0 0 0. We will be able to get these 0 1 bits over here. So what we have to do? We have to perform left shift by length by 2. So let's do that. So what we will do? Answer equals to answer, or left shift of offset left shift length by 2. Okay, so we got this. After this, we got this 1 0 1. Now what we need? We want the reverse of 1 0 1 to be present over here. So it should be something like this. For making the reverse to be present over here, what we will do? We want the reverse of what we will do. We'll first bring 1 0 1 to this location. Okay, 0 0 0. After that, what we will do? We will reverse this number. So it will get converted to 1 0 1. Will get converted to 1 0 1 only. Reverse of 1 0 1 will be 101 only. After that we'll perform the OR operation between these two, so it will get converted to 101 101. So we'll get our answer. So for that, what we'll do, how we can get this 1012 over here? So what we will do, we'll make a new variable. Let's make a new number equals to what, whatever is our answer left shift of answer right shift of length by 2. If you left shift right shift answer by length by 2, means that is by 3 times, so it will get converted to something like this, 0000101. This is equivalent to this number. Okay, now we reverse this number. After getting the reverse will be same for this number. So 101000 and 000101. Now if we perform the OR operation, we get reverse also. Okay, reverse will be same, 000101 for this number. After, if we perform the OR operation, so we'll get our answer, right? So let's do that. So what we will do, let's make a new number, integer, new number equals to answer right shift of length divided by 2. Okay, now new number will be what, new number equals to get reverse of new number. Okay, after that what we will do, answer equals to answer or new number. Finally what we will do, we will return answer. Okay, now let's write the logic for reverse function. So let's write a function get reverse integer n. Okay, how will we get reverse? Let's suppose we have a representation something like this, 10100101. So how to get a reverse? For getting reverse, what we will do, we'll make a variable answer equals to 0. If the current bit is 1, we'll set current bit to what, 1. If the current bit is 0, we'll set current bit to 0. Okay, after that what we'll do, after that what we'll do, we'll right shift by this number and left shift this number. So let's make current bit is what, 1, so we'll make current bit as 1. After that what we'll do, we'll right shift this number. Okay, right shift this number and we'll left shift this number. Okay, now current bit is 0, so we'll make current bit as what, 1, 0. Again we'll right shift the upper number and left shift the lower number. So this will, okay, now again current bit is what, 1, so our bit will be 1. Okay, now again right shift the upper number and left shift the lower number. Current bit is 0, so we are getting 0. So now if you look clearly, the number was what, 1010, and here what we are getting, 1010 from the reverse, so we are reversing this number. Okay, so this is what we are going to do. So let's make a variable, integer answer equals to 0, while number integer bit equals to what, n and 1, answer equals to what, answer or bit. After that what we are doing, answer equals to answer left shift 1 and n equals to n right shift 1. Finally answer equals to answer right shift 1. Okay, and return answer. Okay, finally in this particular loop, if we continue to do this particular loop, what will happen is that all the bits will get something like this. 0. Okay, and over here here will be some answer. Okay, let's suppose some bits are there, xxx. Now here it is 0, so we write a 0 over here. Okay, now again what will happen, we will left shift it by 1 position and we will right shift it by 1 position. Okay, now here bit is 1, so we will write bit 1. Okay, now what we will do, we will right shift it by 1 position and we will left shift this particular number by 1 position. Okay, now since this number got exhausted, means it is 0, the loop will terminate, but we have an extra left shift over here. Okay, so to eliminate this, we are performing one extra right shift after the completion of the loop. That's why this extra right shift is performed. Okay, so we have done with this part also. So now let's try to run this code. So it is giving us wrong answer, so that means we have done some mistake. Let's check where we have done mistake. We have made counter 1, length 1. We are incrementing the line, 1 left shift, length -1, divided by 2. We are incrementing count, that is correct. We are decrementing also. Offset equals to n minus count minus 1. Okay, answer equals to 1 left shift of length minus 1, that is correct. Answer equals to answer or offset length by 2 left shift, that is correct. New number equals to answer right shift of length by 2, new number reverse, answer equals to answer or new number, that is correct. This is also correct, so everything looks correct. Yeah, here it is the mistake, it is not less than n length, it is less than n. Now let's try to run it. It is giving correct answer. Let's try to submit it. It is getting accepted. So this was for this video.